So numerical problem on equilibrium. Okay, so here if we consider a mass, suppose of weight 100 kg, which is connected with two string in such a manner that this length this length how much I can take, this length consider 1100. Okay, and consider this length 400 mm. Okay, and try to get the concept only. Okay, get the concept so that you can solve easily in exam. And then take this distance as a 960 mm. So now the problem is, I think you can understand easily. Here, if that two string is there, and consider this one is your A, this is your B, this is your C. Okay, and consider this one is a 160 kg of mass. So if it is the problem, then if in the question it is written like that, first determine the tension in the string. For example, string A C. In this string, how much tension is there, and in this string, how much tension is there, string B and C. Okay, this is the problem. So I think it is very simple. Can anybody tell me which theorem we can apply here? Can anyone tell me which theorem we can apply to solve this type of problem?
Lamis theorem.
Yes, simply we can use the, or we can apply the Lamis theorem here. So to put the Lamis theorem, we can take, always remember, we can take the equilibrium point. That should be a point where the all the forces are concurrent. Condition for Lamis theorem is what? All the force should be concurrent, and two is all forces should be co-planar. So these two conditions, if they satisfy these three forces, then we can easily apply the Lamis theorem. So if we solve, first make the, if this is the question, right? So first make the free body diagram. So what is the free body diagram? Free body diagram is when you just put all the forces with respect to any point or any line, then that is called the free body diagram, where all the forces are included, which is similar to the system forces. So here if we draw the free body diagram, how to draw? See, this is your point C, and from point C all the forces are passes, means concurrent force are at point C, concurrent point if we say. Then this should be your mass. So if we convert it into force, so that should be 1600 into 9.81, right? So this amount of Newton force are there. Another is there tension. So at point C, one string is in this side and another string is in this side, right? So in this string AC, it is given a triangle if we consider, and if we see, this length is 1100, and this height is given 960. This is your string, right? A C. So how to find out this theta? If we consider this is theta, then we can easily write tan theta is equal to 1100 divided by 960, right? Yes or no? Tell me. Can we write, right? And this one is, if we consider phi, then how much we'll get for that? This is phi, this is 400, this is 960. So tan phi is 400, 960. So can anybody calculate and tell me? Can anybody tell me their magnitude of phi and magnitude of theta? How much it is? Tan inverse of 1100 by 960. This is tan inverse of 400 divided by 960. So please tell.
Phi equal to 20 degrees, sir.
Phi is equal to 20 degree.
22.
22 degree. And theta is equal to tan
48.8, sir.
8.8 degree. Okay. So what we have to do, we have to simply apply now what? You know this, if we consider this one is TAC, tension in string AC, this is tension in string BC, right? This is your B point, this is your A point. So what you will get, you simply get the different angle. So now you have to put simply Lamis theorem. So 1600 into 9.81, how much it is? How much it is? 1600 into 9.81.
What about the remaining students?
Please tell me.
15,696.
Your voice is not audible properly. Can you tell me, repeat again?
15,696. 5,696.
So what you have to do in Lamis theorem, you all know, you have to put the tension, means the force, and divided by the angle in the opposite side. Here the angle is which one? That angle T of AC divided by this angle, and this is how much? This is sine 180 minus phi, right? And T of BC divided by sine 180 minus theta, and this one is 15696 divided by sine theta plus phi. Is it clear? Is it clear, everybody? Any question? Anyone have any question? Anyone have any question, or shall I move forward?
No, sir, forward.
Okay, so from here you can simply find out T of AC is equal to how much. You easily find out from here, right? On this calculation, means T of AC is equal to, okay, T of AC is equal to 15696 into sine 180 minus phi. We already find out phi value is 22. Just put that value here, divided by sine theta plus phi. you all know what is the value of theta and what is the value of phi. So you can easily find out that one. Similarly, T of BC, you can easily find out 15696 into sine 180 degree minus, sorry, minus theta divided by sine theta plus phi. So in such manner, you can easily find out these two forces. Means, okay, and these are positive value, so it indicates these are the tension. Okay. Now, if anybody is unable to solve in exam similar type of problem, then I think if you draw, this is the free body diagram. So in exam, you can also get some marks, not the full marks, but some marks maybe you can get. Suppose if in final exam this type of problem will come, then they give out of 15 at least 5, 4, 5 they will give, like that. Okay, this is called the free body diagram. Remember this thing. Hello, is my voice audible?
Yes,
Yes, sir.
Okay, so in such a manner you can easily find out how to find means what is the tension in the both cable. Okay. And another type of problem, if you say, suppose in some cases, this is most of the similar type, because what I want to say, that suppose if this type of problem is you can solve, you are able to solve, then I think you can also able to solve similar type of problem. That is, suppose same thing it is there. For example, suppose this one, and suppose here we apply some force, some Newton force we apply, and if we give the all the data of this distance and this distance, right? This is totally same to same, only in case of horizontal this is a vertical, right? So I think you are able to solve this type of problem also yourself. Okay, next, and yesterday I have shown you some problem on centroid. And some problem on equilibrium I have shown. And okay, let's solve some problem on friction also. Okay. Friction, always remember, friction you have to means properly give the direction, as well as the try to understand properly in which direction the force will applied. Okay, let's solve one problem. See, suppose, and remember one thing, sometime you have to find out the coefficient of friction, frictional force, and sometime also, in the present case what I will show you here, you maybe also find out some range of your value which is applied force for to maintain a system is in equilibrium. So let's do some numerical problems so that you are a little bit clear your concept. That is, suppose this is a angle where a body is there, and you have to apply some force. This body has some weight, suppose 500 Newton. And due to this force, for example, due to this force P, suppose your body is an angle of 30 degree. Now consider you have the coefficient. I have already shown you that one is coefficient of static friction, one is coefficient of kinematic friction, right? So in coefficient of static friction, consider this one is 0.25 and consider coefficient of kinematic friction, that is 0.2. If this type of problem is come, okay, you have to find out the range of value of P. Find the range of P to maintain the system in equilibrium. Okay, so this is a one type of friction problem. And where that friction happening? That friction is happening here, this common surface. This is your surface. So how to solve this type of problem? Remember, for to solve this type of problem, you also first make the free body diagram. Okay, first you have to make the free body diagram. So what is the free body diagram of this considered problem? How to draw? See, this is your body, this is your applied force P. This is already load due to its own weight, and due to static friction, remember this thing, try to understand properly, that you have two force component, and as you apply this force, so one have a tendency to move, means two condition. Try to understand the two condition. One is you resist this body. If we consider body B, if you resist this body B to move in the downward direction, then your frictional force is in this direction. Okay, and your normal force is in this direction, right? And another case is, remember, another case, that is if you have a body, same thing are there, applied force 500, and suppose this is the case where using this applied force you just try to move your body in the upward direction. Okay, so if you move your body in the upward direction, so your friction is in the opposite side. Anyone have any problem in this concept? Two things may be possible now due to this applied force variation, means P should be have some value. If we consider 1, value 2, so value 1 means this one, this case, and value 2 means this case where P is less. It means what? It means you have to apply some value of P so that this body will try tends to move upward, and this is your applied P. This is the minimum P actually, right? This is means we can say instead of value, I think it is better minimum P. This one is maximum P. So minimum value of P is how much? Minimum value of P should be such that should be that amount that you just resist this body to move in the downward direction. Is my concept is clear? Anyone have any question? When, remember, when they are in the question, if it is asked like that, now find out the range. So always remember your body in the inclined plane, your body have a two type of tendency. One is due to its own weight, your body try to move in the always downward direction. So you have to apply a force minimum amount, that is the minimum force to resist that body to move from that position. That is the one case. And another case is case 2, that is the maximum amount of applied force we have to apply to move that body in the upward direction. So that's why we can say we have to find out the range of force, minimum value and maximum value. Anyone have any question in this concept? Hello, or shall I move forward?
No, sir.
So shall I move forward?
Yes, sir.
Okay. See, so this is your concept. So now how to solve this type of problem? Where also we have to apply the first convert, means here we can apply both Lami's theorem also, or we can apply the equilibrium. Lami's theorem, if we convert here, see, one force, two force, three force, four force. But if a system have four force, then it is not possible for us to apply Lami's theorem, right? So a technique we can apply, that is, we can convert this normal and the frictional force into a resultant force. And then if we convert it into resultant force, then we have a three force, right? Resultant force 500 and means 500 Newton force and another P. Then we can easily apply the Lami's theorem. Okay. So how to solve that type of thing? See, see, for this case, we can easily write this is in this direction and this is in this direction. Okay. So your resultant should be in this direction. Okay. So your resultant is resultant, and that result, and oh, another thing is there, you have already given the phi s and phi, sorry, what I why I have written phi, mu it is given na, mu s and mu k. Okay, you have already given mu s and mu k, and remember one thing, that is where it is question, yes. See, another thing which is given, that is this body with respect to horizontal at a angle of 30 degree. Okay, we have to consider that thing also. So how to solve this type of thing? See, this is your, means I think it is easy to draw here. This is your 30 degree. So this angle is denoted as a mu static. Okay, means what? As per mechanics, we can say this is the condition. We can say this one, case one, if we write it case one, we can say this is the impending motion in the downward direction. Okay, impending motion in downward direction. And this is case 2, we can say impending upward direction motion. Okay, so if it is impending upward direction and it is, if it is impending downward direction, so how to solve that type of problem? See, this is your mu s, and this one is your, I think you can easily understand if I write here mu s is tan phi s. Okay, and mu k is 10, sorry, f by n. So you have to solve this thing in such a manner that phi s indicates your resultant force applied direction. If we draw this one, okay, if we draw this one now in a bigger manner, I think you can easily understand then. If I draw in the bigger way, see, here it is 500 Newton, here it is P, here it is I think it is better to show arrow here, not here. And this angle is denoted as a phi s, and this angle is denoted as a as means, how can I show you this angle here? It is great problem. I think now it is little bit clear. See, we can using space vector, we can easily draw it here, but here it is little bit clumsy. So that's why I draw here. It is okay. See, here it is, your body is at an angle of 30 degree, and your resultant is this one. So this one is your phi s. Phi s is this one. Mu s coefficient of static friction, and this is the coefficient frictional angle phi s for the static condition. So this is phi s my, sorry, 30 degree minus phi s, because phi s is less, I guess, right? Phi s is tan inverse of mu s. Hmm. So can anybody tell me what is the value of phi s? This is 0.25. So phi s is tan inverse of 0.25. How much it is then? Phi s is tan inverse of 0.25. How much it is?
14, sir.
So it is a 14 degrees. So it means this one is your phi s 14 degree, and this one is your 30 minus phi s. So finally, if you draw a velocity triangle, or we can say the force triangle here, mm, that is P. Okay. Another one is your 500 Newton. So you have to draw this one as your resultant. Okay, there's three forces. One is this force, this force, this force. So if you apply these three forces, we can easily say that we can apply the Lami's theorem or velocity force triangle formula. So here this one is how much? Can anybody tell me how much is this one? This is your P, this is your 500, this is your 90 degree, means per n, means this is a normal n direction, normal direction. Okay, and this is your perpendicular. So this one is a 30 degree. So can anybody tell me how much it is, this value? How much we have to put? That is
16.
13 minus 5s. Yes, that is 16 degree. So we have to simply apply the sine formula, or we can easily solve this one using how much it is. We have to find out the p, right? So p means p by 500 is equal to 10 16 degree, right? So from here easily find out p is equal to 500 10 16 degree. So how much it is now? We can say it is a first condition. So P minimum. How much it is?
143.3, sir.
143.3. Okay. Now we have to, in the similar method, we have to find out P maximum. This is a range of force, means this is the case of 1, means impending motion in the downward direction. Means this amount 143 Newton amount of force we have to apply in this body, so that along the horizontal position, so that this body will not move in the upward sorry in not move in the downward direction. Now if another means another condition is there na, how much force we have to apply on that body so that that body will impend to move in the upward direction. Okay, so for that what we have to do to solve the case 2, condition 2, what we have to do in a similar manner, we have to make another free body diagram. Okay, draw the body first. Please send me the today's attendance in WhatsApp. Okay, take the screenshot and send it to me. So this one is 500 Newton. This is your P, and this is your perpendicular case. This is your angle of 30 degree. Now the condition is, when your body will try to move in the upward direction, okay, then your frictional force is always in the opposite direction. If your body try to move in the upward direction, so friction force is in the opposite direction, and your this is your normal, this is your friction means here, so this is your normal direction, sorry, resultant force acting direction, and this one should be your phi s. Okay, same, because this is your coefficient of static friction. Like previously your body is like this manner, this manner, and this manner, so that's why wherever you put the resultant, uh, this is your 500, and this angle is 30 plus 5s, means it is 30 plus 14, so 44 degree, right? So in the similar manner, I think you can easily solve, that is a P max is equals to P by 500 is equal to 1044 degree into 500. How much it is? 500 into 1044. Please tell me. How much it is? 500 into 1044 degree.
482.8, sir.
482.8. So it means your range of P is equal to 143 to P to P max is equal to 482.2. This is you have to solve the problem in such a manner. Okay. Uh, okay, let's solve another type of friction problem. Uh, I have already shown you some problem on string, right? A friction problem. So let's solve another friction problem. If the problem is given like suppose this is a pulley and a block, suppose that have a weight of uh, 20 pound, okay, and block B consider the 30 pound, and they are held in such a manner that these two you can see now in this figure. Now if the coefficient of static friction between the two block if considered means in this position here, in this position, if it is given mu s is 0.15 and suppose it is 0 in this means mu s between b and mu s between b it is 0, mu s between ab it is 0.25, sorry, 0.15. So you have to find out the theta, so that means this angle theta uh, for which the motion is just a impending motion. Okay, you have to find out that angle. I think the problem is understandable to all of you, that two block are there, one block this way another block this way, they are connected with a pulley in using a string, and you have to find out the theta amount so that if you write it here, theta amount so that they are impending in motion. So in this type of problem how to solve? First, remember, first we have to make the free body diagram. So the free body diagram for this block, how to draw? See, for block A, it is already shown here like this. So here it is a tension and it has some weight. For example, here it is 20 pound, right? And if this body try to start impending motion, what does that means? That means your body means block B will move in the downward direction, and if block B move in the downward direction, then block A should be in the upward direction, right? And if block A move in the upward direction, then remember frictional force in the opposite direction only, and along with this your normal force is this one. Clear? Similarly you have to do the free body diagram for block B. For block B, what you have to do in a similar manner, here na string is there, two body connected, this one and this one na. So what happened for block B? String is there, and as these body move in the downward direction, so friction force in the opposite side. But here, as per question, there is no friction force, na? So only it here in this direction is downward, it means this direction in the upward direction. So this is the f of AB, and this one is your, oh, another one is its own weight, that is 30 pound, na? And this is your normal of that force, frictional force AB. So here up to this in the free body diagram, anyone have any confusion? Anyone have any confusion?
No, sir.
Is it clear, right? Now I think you can easily in the similar manner in the previous one which I solved in the similar manner, I think you can find out the result and you can easily solve this problem also. Same, the concepts are same, only the problems are different. Tell me, solve the problem or I have to again write it here? Okay, I want to tell one thing. Here you can apply also the Lamis theorem by finding out the resultant of the f and n, right? But you cannot apply the Lamis theorem for block 2. Is my statement is right or wrong? Can I apply the Lamis theorem here?
No, sir.
Why not? Can you tell me the reason behind that?
There are more than three, sir, forces.
They are more than 3, though the, if we find out, suppose see here it is FAB and the normal is NAB. If we make the FAB and NAB as a normal, then can I apply Lamis theorem? In that case, can I apply? No. The answer is no. In that case, we cannot apply. Why? Because see, this is the resultant. This is the one force will come here, one tension, one normal, and one its own weight. So 4 force. After converted into the resultant force, after that also we have 4 forces in a system, which is applied on a block, right? So for that reason, we cannot apply the Lamis theorem here. So what we have to apply? Simply find out summation of fx is equal to 0 and summation of fy is equal to 0. And another thing is, when any body when any body is in such a angle, na, take your coordinate like this as your x and y, so that you can easily solve the problem. Okay, remember this thing. This is the technique to solve this type of problem in a easier manner. Means if this is your x, this is your y, so you cannot resolute these force components into different parts. Okay, so if it is fx, if we write the fx equilibrium equation, what can we write? Minus t, because fx means this is a minus t in that direction, na? Minus t minus f of ab and minus f, which is nothing but 0, and these we can resolve into the 2 components. wait. So plus 30 cos theta, which we have to find out. And another thing is minus n of AB plus n, which is this one, and minus 30. This is your theta. So one is cos theta, one is sin theta. So minus sin theta. Any forces are there? 1, 2, 3, 4, 5, 6. Total 6 force. So 1, 2, 3, 4, 5, 6. So this is your 0. So you can easily solve this and you can find out the results. Okay. So I end my lecture for today here. Anyone have any confusion? You can ask, or I end my lecture here.
Sir, can you give important?
Uh, Voice is not audible properly. Can you tell?
Can you give important questions, sir?
Important question. Whatever I have just give all the example numericals and the concept. These are all important. Whatever friction problem, centroid problem, whatever the equilibrium problem till now I have done. Okay, all are important. Only in case of unit 1 and unit 2, and I already told you that in exam some problem may come from friction, some on equilibrium, some on centroid, because unit 1 and unit 2 consist of these things. Okay, just I have every day I give you some notes na, so just go through that notes only, and some numerical problem which I solve in the class only, means all the question will come including this thing only. Okay, very less, that is every day how much, only 9 to 10 page I guess. So how much it is? Approx 70-80 page in total and written, so it is easy, you can easily go through this thing. Okay, so I end my lecture here. Any conceptual related question? Friction, equilibrium, centroid. See, center of gravity in unit 2, sorry, in midsem 2, CGMI, moment of inertia, these are in your midsem 2. That is not included in midsem 1. If you just see, go through your, what that called, syllabus, then you can easily understand. No need to, presently, no need to go through the moment of inertia part. Hmm? Okay, I end my lecture here. Thank you.